Hello, this is Adam Craig. I'm going to talk through how to solve systems of equations using matrices. This would come after students have learned how to solve systems using substitution, elimination / combination, or graphing. So I'm talking about matrices on the graphing calculator, either used to check your work or to solve systems that are more complicated than usual, and you don't want to go through the tedious steps of the other methods. So here we go. First things first. Inverse means reverse. And we typically use what looks like a -1 exponent as a symbol to show that. Now the thing about inverses is that they undo each other. Very mathematical word there, undo. Anyway, if I had an equation like a times x equals b, and this actually, if it meant times, like it looks here, I would solve for x by using the inverse. Inverse of multiply is divide, so I divide by a, I divide by a. I would isolate x and have my solution. I'm going to do that same basic idea, but let's show it using this notation. Inverse of a times a. Once again, because that will undo what a did. And then the same thing on the other side, of course, to keep my equation balanced. Now we'd call this type of operation on the left canceling out. So I'm doing that to cancel out a. I am left with x. Bring down my equals, of course. And then this a inverse times b is what I would type into my calculator to get my solution, just like usual if I'm solving an equation, right? But my answer is going to be a matrix. And if I was solving a system of two equations with two unknowns, then my x is actually going to represent two variables, x and y. So my answer is going to have two values in it, one for x and one for y. Let me show you what this looks like doing a problem, and we'll go from there. I took this example from page 125 in the Algebra 2 book. The first equation is 3x plus 7y equals 15. The second is 5x plus 2y equals -4. Now I could use substitution or elimination or graphing to solve these, but there's not really a convenient way. I'd probably use elimination because they're in standard form, all nicely lined up. But I'd need to multiply each equation by a different number if I wanted to keep the numbers whole, etc., etc. It gets a little more complicated. Here's how we would turn them into matrices to use our graphing calculator. Step 1. I need matrix A. This is called the coefficient matrix. You'll use these coefficients on the left side of my equation, 3, 7, 5, and 2. And then times x is going to be my variable matrix. In this case, my two variables are x and y. And it equals b, which is my constant matrix. So 15 and -4 are the values in there. Once again, just to label briefly, this is matrix B. And way back over here is matrix A. And that big one is my matrix X idea. I'm not going to squeeze that in there just because of space. But now it's time to put this into my calculator. Now the calculator button for matrix is in a similar location for different calculators, but not identical. On my TI-83, it's its own button. I believe on the 84s, here's a blue version of that, it's nearby, but a second feature. So you look in that general area, and push matrix, and it lists your different matrices. It shows what's in there currently. I have a couple 1x1s, which I don't want for this. I'm going to go over to edit. I want to edit A first. I need to tell it the dimensions. Matrix A is a 2 by 2, so 2, enter, and the values are 3, 7, 5, and 2. All right. So matrix A is the 2 by 2 matrix that I want. I'm going to quit out of that, go back to my matrix. I like to edit B. So I go over to edit, down to B, push enter. B, way over here, is a 2 by 1. So I'll type in 2 by 1, and the values are 15 and -4. All right. So if I look back up here to our work, this side canceled out, right? And I was left with X. So this shows what I want to actually type into my calculator. The inverse of A times B. Let's do that. I'm going to quit, back to my home screen. I'd like to type inverse of A. So first I need to find A. It's back under my matrix button. Push enter. The inverse button is right here under math. And there it is. Inverse of A. Times B. So times, back to matrix, down to B, enter. Let's check. Inverse of A times B, enter. Aha. -2, 3. So what that's saying is, if I go way back down here, when I isolate this, I end up with -2, 3. So my solution to this system, way back at the beginning, is -2, 3. Obviously, you could confirm that using any of the other methods, and I'd encourage students to do that, of course, to keep that review and to see the connection. You could even, I'd probably go to Desmos online and type these in as they are right there. You don't need to solve for y or anything, and just see that they do indeed cross at -2, 3. What a great thing. All right. Hope you found that helpful. Thank you in advance for trying this in class, and of course, see me with questions. Have a great day.